Hi everyone, welcome to FatMath. In this video, we will have inscribed angles and intercepted arcs. So let us start. Inscribed angle. Angle whose vertex is on the circle and whose sides contain chords of the circle. An intercepted arc is the arc that lies in the interior of the inscribed angle and has endpoints on the angle. So we have here three cases. So for the first one, we have here angle ACB is the inscribed angle. So it's formed by rays CA and rays CB. And the intercepted arc of this angle is the arc that lies in the interior of the inscribed angle and has endpoints on the angle. So the endpoints are A, B. So the intercepted arc here of angle ACB is arc AB. In this case, same, but we have here a diameter and a ray here. So the center of the circle falls on one side of the inscribed angle. So angle C is the inscribed angle, and angle AB is, arc AB is the intercepted arc. Same here. So we have here two chords. Angle C is the inscribed angle, and arc AB is the intercepted arc. Okay, theorem. If an angle is inscribed in a circle, then the measure of the angle is equal to 1/2 the measure of its intercepted arc. Equivalently, the measure of the intercepted arc is twice the measure of the inscribed angle. So in this video, we will just apply these theorems here. We will no longer go to the proof. So maybe in your regular class, in your mathematics with your teacher will present to you how the how we came up with this theorem. So for example, we have this illustration. So we have here angle ACB, the inscribed angle, and arc AB is the intercepted arc. So it says that the measure of this angle ACB is half the measure of this arc AB. Or you can say that the measure of this arc AB is twice the measure of angle C. So for example, if this is 30 degrees, angle C is 30, arc AB is 60. If this is 40, arc AB is 80 degrees. Okay. For example, if measure of angle ACB is 43, if this is 43, what is the measure of arc AB? So it's just times 2. 43 times 2. That is 86. That's right. 86 degrees. How about if the given is arc AB is 90? What is the measure of angle ACB? So you just divide 90 by 2 or take half of 90. That is 45 degrees. Okay, another. Given that the measure of arc AB is 9x minus 12 and measure of angle ACB is 4x degrees, find the value of x. So let us solve for x here. So our theorem states that the measure of the arc, the intercepted arc, is twice the measure of the angle. So the measure of the arc, which is 9x plus 12, is equal to 2 times the measure of the angle 4x. 2 times 4x is 8x, and then solving this linear equation, we will put terms with x on one side and those without x on the other side. So transferring 8x here to the left will give you negative 8x. Transferring negative 12 to the other side, you will get positive 12. And 9x minus 8x is x. So x equals 12. So x is 12. To solve for the measure of angle ACB, we can just replace 12 here. Just solve for 4x. So 4x is 4 times 12, or that is 48. What is the measure of arc AB? So arc AB is 9x minus 12. So that is 9 times 12. So because x is 12. So minus 12. So this is 108 minus 12. So that is 96. Or you can just apply the theorem that the measure of this uh, arc AB, so there should be no angle here. Remove this. So the measure of arc AB can just be 48 times 2. So 48 times 2 will also give you 96. Or you can just do this. So 9 times 12 minus 12. Okay, let us have another theorem. Two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc. Then the angles are congruent. If two inscribed angles of a circle or congruent circles intercept congruent arcs or the same arc, then the angles are congruent. Okay, let us have the first example here. In this case, we have two inscribed angles that intercept congruent arcs. So if these two arcs AC and FD are congruent, then this angle B here and angle E are also congruent. So that's what it says. Or of the same arc. So this is for congruent arcs. How about if we have the same arc here? So we have here arc AB. Arc AB is the intercepted arc of angle D and angle C. So since these two inscribed angles intercept the same arc, then these two inscribed angles are congruent. Meaning to say, if angle D is 30, this angle C is also 30. So they have the same measure. Okay, let's have an example. Given the measure of angle ADB is 8x minus 14, ADB is this one, and angle ACB is 6x plus 2. As what you can see here, these two angles intercept the same arc AB. So as what the previous theorem states, these two angles must be congruent. So their measures are equal. So this 8x minus 14 is equal to 6x plus 2. And then solving for the equation, you put 6x to the left. That's going to be negative 6x. And you put negative 14 to the other side. It's going to be positive 14. So 8x minus 6x is 2x. And then 2 plus 14 is 16. So divide both sides by 2. You will get x equals 8. So x is 8. Measure of angle ADB is 8x minus 14. So replace that. The value of x is 8. So replace x with 8 in this one here. 8 times 8 minus 14. 8 times 8 is 64. And 64 minus 14 is 50. So the measure of angle ADB is 50 degrees. So this is 50 degrees. So if that is 50, ACB is also 50 since they are congruent. How about arc AB? So arc AB is the intercepted arc of these two inscribed angles. So it's twice the measure. So 2 times 50, 100. Okay, another. If an inscribed angle of a circle intercepts a semicircle, then the angle is a right angle, like this. So if this inscribed angle ABC intercepts semicircle AC here, then this one is a right angle. Of course, a semicircle is 180 degrees, and the inscribed angle is half of that. So half of 180 is 90. That's why it's a right angle. Okay, example, if AC is a diameter and of circle O, and measure of BC is, arc BC is 124 degrees, find the measure of angle BAC. So BAC here is an inscribed angle intercepting 124, so that's half of 124. Because here the endpoints are here. So half of 124 is 62. So measure of angle BAC is 62 degrees. So this is 62. How about the measure of arc AB? Arc AB here and arc BC, which is 124, make a semicircle. So the total of these two is 180. So how are we going to solve for AB? This is just 180 minus 124. So 180 minus 124 is 56. So this arc here is, arc AB is 56 degrees. How about the measure of angle ACB? Angle ACB is an inscribed angle intercepting 56 degrees. So half of 56. Half of 56 is 28. So 28 degrees. Okay, another line segment BD here is a diameter of circle O. If measure of angle DAB is 3x minus 9 degrees and ADB is x plus 20 degrees, find x. So since BD is a diameter, this angle DAB here is a right angle because it is intercepting a semicircle BCD. So this has to be a right angle. So if that's a right angle, so 3x minus 9 is equal to 90 degrees because the measure of the right angle is 90 degrees. Solve the equation. Okay, so add 9 to both sides. You will have 90 plus 9. That's 99. Divide both sides by 3. That is 33. So x is 33. So if x is 33, the measure of angle ADB is x plus 20. So 33 plus 20 because x is 33 as what is solved here. So that is 53. So measure of angle ADB is 53. Where's ADB? ADB. So this one is 53. Measure of arc AB. Arc AB is the intercepted arc of angle ADB. So that is twice the measure. So 2 times 53. Because this is 53, the inscribed angle. So the intercepted arc is twice. So 106 degrees. How about the measure of arc AD? So arc AD here and arc AB make a semicircle. So arc AB is already 106. So we just subtract 106 from 180. So 180 minus 106, that is 74. So this is 74 degrees. And ABD is half of 74 because AD is the intercepted arc of the inscribed angle ABD. So that's half of 74. That is 37 degrees. So this one here is 37. Or you can also use the angles of a right angle here. This is already 90. So these two must be complementary. So the sum is 90. So you can just have 90 minus 53. That is 37. You can also use that process. Okay, we have here the last theorem for this video. If a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. When we use, say, a quadrilateral is inscribed, then its vertices are points on the circle, like this. Like this illustration, all the vertices of this quadrilateral are on the circle. So when you say supplementary, then the sum is 180. So this angle B and angle D add up to 180 degrees. Same with angle A and angle C. Because the total intercepted arc, okay, for example, angle A, the intercepted arc is major arc BCD. The intercepted arc of angle C is minor arc BAD. So the total of the two arcs is going to be the whole circle, which is 360 degrees. And each of these is half of the total, half of the intercepted arcs. So the total or the sum of the two angles will also be half of the total intercepted arcs, which is 180. So half of 360. So half of 360 is 180. Okay, let us apply that theorem in this example. Quadrilateral ABCD is inscribed in the circle as shown here. If measure of angle A is 110 and measure of angle D is 75, find the measure of angle C. So angle C and angle A must add up to 180. So how do you get C? Just subtract 110 from 180. So 180 minus 110 is 70. So measure of angle C is 70. How do we solve angle B? Angle B and angle D are supplementary. So their sum is 180. So we know that D is 75. So B is 180 minus 75. That is 105 degrees. How about measure of arc BCD? Where is arc BCD? Arc BCD is from here going here. It is the intercepted arc of angle A. So it has to be twice the measure of angle A because angle A is this. So the intercepted arc is BCD, so that's twice. So 2 times 220. How about ADC? ADC is this one. It is the intercepted arc of angle B. So twice the measure of angle B. So twice of 105, 210. Measure of arc AC. Arc AC, where's arc AC? This one. Arc AC is the intercepted arc of angle D. So twice the measure of angle D, 150. BD, here this one, intercepted arc of angle C. So twice the measure of angle C, twice of 70, 140. Okay, so that's it. So for an inscribed quadrilateral, opposite angles are supplementary. Last example, quadrilateral EFGH is inscribed in the circle shown. If measure of angle E is 2x plus 32 degrees, measure of angle F is 3x minus 5 degrees, and measure of angle G is x plus 13 degrees, find the following. Okay, so what are we going to use here? We have to use E and G are supplementary, meaning to say their sum is 180. So if we add 2x plus 32 and x plus 13, the answer must be 180. So here we have 2x plus 32 plus x plus 13 is 180. 2x plus x is 3x. 32 plus 13 is 45. Copy 180. And put 45 to the other side. So that's going to be 180 minus 45. So that's 135. Divide both sides by 3. You will have 145. I mean 45. So x is 45. Measure of angle E. Angle E is 2x plus 32. So x is 45. So 2 times 45 plus 32. That's 90 plus 32. That is 122. So measure of angle E is 122 degrees. Measure of angle G. Angle G is x plus 13. X is 45. So 45 plus 13 is 58. Or you can have E is 122. And G and E are supplementary. So you can just subtract from 180. So 180 minus 122, that will also give you 58. Measure of angle F is 3x minus 5. Replace x with 45. So 3 times 45 is 135 minus 5. That is 130 degrees. And measure of angle H. Angle H is a supplement of angle F, or their sum is 180. So subtract 130 from 180. That is 50. So measure of angle H is 50 degrees. So only 50, not 150. So H is 50 degrees. Okay, so that's it for inscribed angles and intercepted arcs. Comment down below if you have some questions and clarifications, or if you have some items related to this topic, you can ask me in the questions or in the comments and I'll try to answer. So that's it for this video. I hope that you learned. So thank you so much for your support to FatMath TV. Bye!